Okay, today we're going to do a little bit more with sedimentary rocks. We're going to talk a little bit more in depth about how we get sediment and how that sediment is transformed into rock. So first, a brief review of what a sedimentary rock is. Remember, a sedimentary rock is a rock that is made up of fragments of other rocks, plants, or animal remains. Sedimentary rocks make up about 75% of the rocks on the surface of the earth. So that doesn't mean that 75% of all rocks on earth are sedimentary rocks. That's just on the surface. So you go beneath the surface and you start getting the other types of rocks. There are a couple types of sedimentary rocks. We got clastic and bioclastic and crystalline or evaporites. Clastic are made by compaction and cementation of sediments, and they are identified by the size of the fragments. So to get clastic rocks, this is where we're going to start talking about how we get the sediment. So in order to form clastic rocks, we have to first have sediment. Now to get sediment, we go through a process called weathering and erosion. So weathering basically is breaking down rocks. So rocks on the Earth's surface are broken down into smaller pieces called sediments by a process of weathering. So weathering is the process of breaking those previous rocks down into sediment or rock fragments. There's two types, physical weathering and chemical weathering. Chemical weathering is when a rock is dissolved or chemically changed through some sort of chemical reaction. Maybe it's mixing it with water or acid rain or something like that. Physical weathering is when they are physically broken down. So if you were to take a rock and hit it with a hammer and break it, that would be physical weathering. So some examples of chemical weathering. It basically results from chemical reactions with carbon dioxide and rain. That's one example. Oxygen or just plain water. So if you look at the picture of the gravestone here, this is limestone, and this gravestone reacted with carbon dioxide and rain or acid rain, and it's starting to break that rock down through an actual chemical reaction. On the right here we have a car that is oxidizing, which basically oxygen is reacting with the metal and forming rust. So this also happens in rocks as well. Physical weathering results from erosion by moving water, so rain, rivers, or waves. So rain coming down, pounding on the ground can break up the rocks. Rivers can move the rocks around, tumble the rocks, and break them up in that way. Same thing with waves. Wind is another factor. So wind blowing across the surface can cause erosion, which if you look at the picture that's here, this is actually a picture of something in northern Arizona. It's called the wave, and this was formed by wind blowing over the surface for millions and millions of years, and it creates this really cool wave-like pattern. Gravity is another one. So gravity causes things to fall towards the earth. So if you have a steep slope, any sediment or rocks that are on that slope could potentially fall and be pulled down due to gravity. Glaciers can come through and break up rocks, and then animals can also break up rocks. If you think of us as humans, we're animals. We break up rocks all the time, whether it's in quarries for mining or just to move stuff out of our way so we can build roads or whatever. We're constantly weathering rocks ourselves. So some examples of how water or physical weathering could work. This is the Colorado River. This is the Grand Canyon, or part of it at least. This river here, over the years, has wound its way back and forth through this terrain, and it's carved its way down into the earth. Same thing here, you can see the different layers that it has cut through on its way down. At one point the surface was up here at the top, and that river flowed right around the top. But over millions and millions of years, it started to eat away as it flowed through, and it washed all that sediment away. Another one, glaciers. So as this glacier moved down the mountain, it carved its way through the mountain and broke up the rocks and brought them down to the bottom here where they deposited. This would be an example of gravity pulling the rocks down. So we call this mass wasting. This type of mass wasting would be a landslide. So over time, the rocks and the sediments on that slope start to get really heavy, and they will be pulled on by gravity, and at some point they just can't take it anymore, and they start to break and collapse, and it's no good for these houses down at the bottom here. So after weathering, we get deposition. So the rock is broken down in smaller pieces. It's eroded away, meaning that it's carried somewhere else. And then it's deposited. So it says after rocks are weathered, sediment can be transported by running water, wind, ice, and animals. So all of those things could cause the sediment to move somewhere else. When the transporting agent dies down, the largest sediments are deposited first. So when the river that is transporting the sediment starts to die down, so maybe up at the top of the mountain here, the river's flowing very fast, so it carries heavy sediments with it. It can carry larger boulders. When it gets down to the bottom, where it starts getting flatter, it starts to slow down, so all that stuff the heavier stuff starts to drop out of the river and deposit on the bottom of the river. And then finally, when it meets the ocean right here, the ocean basically stops that river from flowing. So once it hits the ocean, it stops that river from flowing, and all of the sediment that was floating in that river is now just drops to the bottom of the ocean, and that's where it stays. And it creates something called a delta. So this would be a picture of a river delta right here. So this water has been flowing out here, carrying lots and lots of sediment with it. When it reached this point, the mouth of the ocean, it stopped flowing and all that sediment deposited. You can see this delta here, this big old area of deposition where all that sediment has just been piling up for years and years and years. Okay, sorting happens when sediment is deposited and sorted by grain size. So we talked about the water slowing down, and when it starts to slow down, the heavier stuff falls out first, and this leads to sorting. So the heavier stuff, the bigger stuff will be on the bottom, and the smaller stuff will be on the top. So you get something that looks like this. So our bigger stuff's on the bottom because that will fall out first as the river starts to die down, and then we get smaller stuff on top of that, and it's even smaller still, and then our very, very tiny fragments up here that you can't even see when the river or whatever it was starts to really just die out completely. Okay, lithification. This is a term you're going to need to know pretty well. It will be on the final. Lithification is the process of turning sediment into stone. So when sediment is deposited on the bottom layers are subject to increased pressure and temperature. And when you get that increased pressure and temperature, you get compaction. So they're compacted together by the weight of the top layers. So it squishes it and compacts it and binds it together into a rock. So we got pressure coming down from layers and layers of rocks being deposited on top of this, and over time it's buried so deep that there's so much stuff on top of it that it's compacted down into a rock. The other type of lithification is cementation, and that occurs when mineral growth occurs between sediments and glues them together and forms a solid rock. So you have these sediments here in this picture on the left. All this white stuff is sediments, and the red stuff in between it is minerals that grew in and cemented all those together. Finally, bedding. Bedding is horizontal layers of sediment that formed by differences in deposition. So there's two types, graded bedding and cross bedding. This would be an example of graded bedding in the picture here. Basically, this happens over millions and millions of years. Each one of these layers is deposited in a different time period. So maybe this time period here represents 10 million years. This time period of deposition might be 100 million years. So this stuff right here was deposited over the course of 10 million years, and so on and so on. So this rock outcrop here represents millions and millions of years of deposition. And so there's differences in deposition and deposition rates. That's why you get the layering. Okay, that's it for sedimentary rocks. So next will be metamorphic rocks.